class on kinematics. You may be knowing that is kinematics is a branch of dynamics. If we see what are the branches of mechanics, mechanics is primarily broken into two branches, or it has two branches. One is statics. In statics we deal with the bodies when they are stationary, and the other branch is dynamics. Over here we deal with the bodies when they are moving. In dynamics we have one is kinematics and the other is kinetics. In kinematics we study motion, how the motion is taking place. All the equations of kinematics like V is equal to U plus AT, V square minus U square 2S, S is equal to UT plus half AT square, distance, displacement, velocity, speed, etc. all is read under kinematics. In kinematics we are not bothered about that is what is causing motion. So in kinetics we talk about the forces. Over here we are purely studying that is how the motion is taking place. In statics we deal with the bodies which are stationary, and in dynamics we deal with the bodies when they are in motion. So when we say motion, the one thing to understand is that is rest and motion, they are the relative terms. People sitting in a moving train, they may be stationary with respect to each other, but with respect to a person on the ground who is seeing this train moving, with respect to him all the passengers, they are moving in one direction. When we are sitting in a chair, we may not be moving. That is, we are at rest or we are not moving with respect to earth. But with respect to moon, the earth is moving. And when the earth is moving, all the bodies on earth, they are also moving with respect to moon. So rest and motion, they are the relative terms. So now the question comes, that is, who will decide whether the body is at rest or the body is in motion? A passenger who is sitting in a moving train, with respect to him, all the other co-passengers, they are stationary. But with respect to a person on the ground who is seeing this train moving in a particular direction, with respect to him, all the passengers, they are having some speed or velocity in a particular direction. So the question comes, that is, who is right? It's both of them, they are right. It is when we say that is rest and motion, they are the relative terms, it is with respect to. All the passengers, they are moving the train with respect to a person on the ground, and all the passengers, they are stationary with respect to a person who is sitting in the train itself, provided that is passengers, they are not moving in the train. So rest and motion, they are the relative terms, and if we have to decide that is whether the motion is taking place or not, first is we have to fix the observer, that is who is the observer. We have to fix the observer, or in the other way we say that is we have a reference frame. So first thing is we fix a reference frame, and with respect to this reference frame, if the coordinates of any body, they are changing with time, we say motion is taking place. One of the types of reference frames is Cartesian coordinate system, where we have x-axis over here, this is x-axis, this is x dash, over here it is y, and over here is y dash. These are perpendicular to each other, and over here we say this is origin. As we have x and y axis, similarly up the plane there is a z axis, and down into this board it is minus z axis. So we have three axes, x axis, y axis and z axis. All these three axes, they are mutually perpendicular to each other. This is a Cartesian coordinate system. Now we can mark few things, 1, 2, 3, and this way it is negative, minus 1, minus 2, minus 3, minus 4 and so on. Similarly over here it is positive, 1, 2, 3, 4. In the downward direction it is negative, minus 1, minus 2, minus 3, minus 4 and so on. Now once we have fixed this reference frame, or we have fixed this observer, all the points in the universe, they have a unique set of coordinates at any given point of time. If we have a particle over here, its coordinates in the term of x, it is 3, y is 2, z is 0 because it has not been lifted up the board. So the coordinates of this, they are 3, 2, 0. X is 3, y is 2, z is 0. And if it is over here, so it is x is over here is minus 3, y over here is minus 3, z is once again equal to 0, because this point lies on the board itself. If this point is lifted in this direction, then there is going to be a z coordinate also, which is going to be positive, and if the point lies behind this surface, then z is going to be negative. Now when we say the motion has taken place, it means with time these coordinates of any point of any body that should change. Like if there is a particle which was initially over here and then it moves, or insect over here which crawls to this point, from A to B it has gone. If it has crawled and it has gone from here to here, then how do we define motion? We define motion, that is, if any of the coordinates defining its position, that is x, y and z, we require these three coordinates to define the position of any object or any body. Over here we are taking all the bodies as point mass bodies. So if any of the coordinates of this particle or this body, it changes with time, we say that is motion has taken place. If out of these three coordinates, if only one coordinate changes with time, we say it is motion in one dimension. If two coordinates they change with time, we say motion in two dimension. And if three coordinates they change with time, we say motion in three dimension. The case of motion in one dimension is, suppose an insect, once again we take the example of insect which is going in this direction. So when it is going in this direction all the time, over here, B over here, B over here, B it over here, we are taking arbitrarily 3 points. Any points you can take. So over here, X is all the while, B it over here, B it over here, B it over here, X is going to be -3. But Y is changing. Y is what? Over here, it is 0. Then when it comes over here, it is 3. When it comes over here, let's say it comes out to be 5. So Y coordinate is changing, and Z, it is not moving up or down this surface. So Z coordinate, it remains as 0 only. So out of three coordinates, it's only one of the coordinates, that is Y is changing. We say motion in one dimension. Similarly, if a body is going in this direction, let's say it is moving in this direction. So now what is happening is Y is constant all the time, it is 3 only. It is only the X coordinate is changing. Z coordinate is also not changing. So it is once again motion in one dimension. But if the body, let's say it is moving like this. So what is happening is we take any arbitrary 3 points or so. Over here X is this much. Over here X is this much. So X is changing. We see that is X is changing. What about Y? When it is over here, Y is this much. When it is over here, then the Y is this much. Y is this much. So Y is also changing. Z is not changing because it is not moving up the surface or down the surface. So out of three coordinates, X, Y and Z, X and Y, they are changing. So we say that is its motion in two dimension. But what about if there's a bird? The bird flies like this. If the bird flies like this, then certainly X coordinate is changing, Y coordinate is changing, and Z coordinate is also changing. So this is motion in three dimension. So depending upon whether one of the coordinates defining its position that is changing, then it is motion in one dimension. If two coordinates out of three they are changing, so this is motion in two dimension. If three coordinates they are changing, we say motion in three dimension. Now let's understand some basic terms which we shall be using extensively in our understanding of the topic kinematics. So one is distance. We say it is distance, and we also have word displacement. So we have distance and we have displacement. If a body goes like this, from A to B, it has gone like this, it has taken this path. So this total length of path, this is called distance. This length, it can be measured in meters also, centimeter also, millimeter also, kilometer also, light year also. So they are all units of length only. So this length of path, that is called the distance. Distance is a scalar quantity. It has got only magnitude. As you know, we have scalars and we have vectors. When we talk about scalars, they have only magnitude. That is, they have a pure number, they don't have any direction. So when we say distance, distance is this total length of this path, it is called distance. When we talk about displacement, displacement is from initial to final, connect by shortest path and put an arrow over here. Simply saying that is, this is displacement. No, this is not displacement. Displacement is a vector quantity. This is scalar. This is scalar physical quantity, and this is a vector physical quantity. Vectors, they have a magnitude also, they have a direction also, and their addition, etc., that is also governed by vector algebra principles. Over here, this length is the distance, and the shortest distance between A and B with an arrow on its head, this is displacement. If the body has gone from here to here, that is from B to A it has gone, then the displacement vector is going to be like this. Now all the time we have been moving. Since our birth we had been moving. So what is our displacement? Whenever we say what is our distance or what is displacement, always associate it with time. Let's say there is a student, he goes for the school. Let's say there is a student, he is a point mass. He goes like this throughout the day, and over here it is 8 a.m. and at 8 p.m. his coordinates, they are like this. So someone says, what is his displacement? We'll say this is his displacement for a day, let's say 20th of November 2020, between 8 a.m. and 8 p.m. this is the displacement. If at 5 p.m. this person is over here, then between 8 a.m. to 5 p.m. on this date, the displacement is like this. So always associate the distance and displacement with respect to time. And if a body starts from one position and eventually comes back, let's say a body goes like this, goes like this, goes like this, comes back to this. So for the entire journey, the displacement comes out to be equal to 0, whereas the distance is not equal to 0. Distance is still this length of this path. So distance is not equal to 0, but displacement is equal to 0. Then we say speed. Speed is distance upon time. Speed is, let's say when we say it is 50 km per hour, it is not necessary that the body has to move for 1 hour. It means if at that speed, this body maintains this speed for 1 hour, this person will travel 50 km in 1 hour. Speed, it doesn't have any direction. When we say velocity, velocity is speed in a particular direction. When we say a person is moving with 50 km per hour towards east, so we have both the things. We are saying that is what is the magnitude, it is 50 km per hour, and towards east, that is direction also. So this is the velocity of the body. When we say speed, it is primarily we are saying instant speed. Obviously, when we are going from position 1 to position 2 through the roads, there could be traffic blocks, there could be speed breakers, or there could be other reasons, so that we may slow down or we may increase the speed during this journey. So it means all the while our speed is not constant. So at any instant, what we say is the speed, it is a speed at that instant only, that is, it is instantaneous speed or instantaneous velocity. Now we have other terms like average speed and average velocity. When we say average speed is total distance upon total time, and average velocity is net displacement upon total time. So over here is total distance, over here is net displacement. So average speed is total distance by total time, and average velocity is net displacement by total time. If there's a person who goes from here to market, he goes 5 km this way, comes back 5 km this way, and total time, suppose he takes 1 hour. So someone asks, what is the average speed and what is average velocity? As far as the average speed is concerned for this whole journey, the total distance is going to be what? 5 plus 5. 5 forward journey, 5 is reverse journey or backward journey. So it is total distance is 10 km. And how much time he has spent? It is total is 1 hour he has spent. So it is 1 hour. Total distance by total time. So this is, we say this is average speed is going to be 10 km per hour. But if we have to find what is the average velocity, then we have to say what is the net displacement for the entire journey. At t is equal to 0, this body, it was here, this person was here, and at t is equal to 1 hour, after 1 hour, once again he was here only. So the net displacement of this body for 1 hour, that is going to be equal to 0 only. So net displacement is going to be 0 by 1 hour is going to be 0 only. So average velocity is going to be equal to 0 only. So average speed is total distance by total time, and average velocity is net displacement by total time. Now let's understand the term acceleration. We all know that is what does it mean, that is when the car is accelerating or a car is retarding. When we use the term acceleration, acceleration is a vector quantity. It has got both the things, it has got magnitude also, it has got direction also. But let's understand acceleration in terms of magnitude only first. When we say a body is accelerating, generally we mean that its speed is increasing with time. And when we say a car is retarding, it means its speed is gradually reducing with time. Acceleration is rate of change of velocity. When we say acceleration is rate of change of velocity, we are primarily saying that is how the velocity is changing with time. If the velocity is increasing with time, we say this body is accelerating. If the velocity of the body is reducing with time, we say this body is deaccelerating or retarding, or it has a negative acceleration. It is one and the same thing. Let's say a body, this person is going initially at 10 meter per second, and after 1 second, this 1 second has elapsed, and this person from here to here, now he is going at 20 meter per second. Let's remove this. And after 1 more second, 1 second, this body is moving at 30 meter per second. So if someone says, is this body accelerating? So the first thing to see is whether its velocity or speed is changing or not. Yes, over here it is 10 meter per second, now it is 20 meter per second, now it is 30 meter per second. So it means its speed is changing and it is increasing. When there is a change of speed or velocity, we say acceleration is taking place. In this case, the velocity or speed is increasing, so we say it has a positive acceleration. Acceleration is rate of change of velocity. This is given as dv by dt, rate of change of velocity, this is a vector quantity, or we say the final velocity minus initial velocity over time. That is, this stands for change of velocity and this stands for change of time for a very, very small instant. So from here to here, if we say that is change of velocity, if we say this is A, this is B position, this is C position, and we go from A to B position, that is, this is our initial point of observation and this is final point of observation. We say what is the change in velocity? Change in velocity is this velocity minus this velocity, that is 20 meter per second minus 10 meter per second. This is change of velocity, but acceleration is rate of change of velocity. When we say rate, it is generally that is divided by the time. So it is 1 second. So acceleration is change of velocity by time. So this comes out with 20 minus 10, that is 10 meter per second over 1 second, that is acceleration is equal to 10 meter per second square. So acceleration is 10 meter per second square. It means for every 1 second, the velocity is increasing by 10 meter per second. So now if someone asks, that is, if the velocity is more, acceleration will be more or less. Remember that is velocity and acceleration, they are the two different physical quantities. We cannot dare to compare two different physical quantities. We cannot compare meter with the liter. We cannot compare volume with the area. We cannot compare velocity with the acceleration. Acceleration can be compared with the acceleration only, velocity can be compared with the velocity only, distance can be compared with the distance only. Like over here, if instead of this we have a person who is going at 100 meter per second, and after 1 second he has a speed or velocity of 101 meter per second, and now after 1 second he has velocity of 102 meter per second. Once again, the velocity is also increasing over here. Velocity, this is much higher as compared to this. Over here it was 10 meter per second, over here it is 100 meter per second. But what about the acceleration? Acceleration is rate of change of velocity. So if this position we call it as A dash and we call this as B dash, so going from A dash to B dash, we are interested in acceleration. So it is change of velocity 101 minus 100 meter per second upon 1 second. So this comes out to 1 meter per second square only. That is, the velocity is changing at the rate of only 1 meter per second. Whereas over here the velocity was lesser, much lesser as compared to this, 100 meter per second, 10 meter per second, but the acceleration is more. So we cannot compare the two different physical quantities. A body with a higher velocity can have a lower acceleration with respect to some other body. What if a body is going with some velocity and with time the velocity reduces? In that case, we say that his body is deaccelerating or retarding. Let's say here is a body, a car, which is going at 20 meter per second. After 1 second, uniformly its speed reduces to 10 meter per second. So it goes from A to B in 1 second and speed reduces from 20 meter per second to 10 meter per second. We are interested what is acceleration in this case. We know acceleration is equal to, though instantaneous acceleration if we say it is dv by dt, Otherwise, if we directly say acceleration is change of velocity over a period of time divided by total time, so this is the average acceleration. Right now we are just talking about the instantaneous acceleration. We are saying that is from here to here, the velocity is gradually uniformly that is reducing. So that is acceleration is constant. Acceleration is rate of change of velocity. So it means it is, we can say, change of velocity by time taken. By time taken. So what is change of velocity? Change of velocity is final velocity minus initial velocity. Always we take it as final minus initial. So it is going to be 10 meter per second minus 20 meter per second upon 1 second. So this comes out to be minus 10 meter per second square. That is, it is reducing at the rate of 10 meter per second for every 1 second. So over here we say that is acceleration is minus 10 meter per second square, or we say retardation, we say it is 10 meter per second square. So acceleration of minus 10 meter per second square can also be said as retardation of 10 meter per second square. Similarly, a retardation of minus 5 meter per second square means acceleration of 5 meter per second square. So acceleration is negative of retardation, or retardation is negative of acceleration. We have some standard equations of kinematics. They are V is equal to U plus AT, V square minus U square is equal to 2AS, S is equal to UT plus half AT square. These are primarily three basic equations of kinematics, where we say that is U stands for initial velocity, V stands for final velocity, S stands for, depending on the case, it is distance or displacement, T stands for time, it is a scalar quantity, A stands for acceleration. And from these three, we can also derive one more equation, that is the distance traveled in the nth second is U plus half A 2n minus 1. This can also be derived using these equations, that is the distance traveled in the nth second is U plus half A 2n minus 1, where n is that second what we are talking about. This is the distance traveled in a particular second, let's say 5th second, 6th second. Over here when we say t, it is 6 seconds, 5 seconds. Over here 5th second, 6th second. So that is the difference between the two. So using these equations we can easily derive that is the distance traveled in any nth second is U plus half A 2n minus 1.